All right, guys. So I got some requests. Some people were using Google Custom Search, and in looking at Google Custom Search stuff, I thought it might be a good opportunity to kind of introduce you guys to the wonderful world of web scraping. So I did a bit of web scraping in the past using a couple of different languages, and one of the good things about it is it looks like it's easier to do now than it was when I used to do it. So I put together a little program. I'll show you guys how it all works and whatnot. So who knows what web scraping is in here? So just basically a couple of yous. Okay. So before we begin, we got to do the disclaimer. With great power comes great responsibility. So web scraping, it's one of those things that falls into a gray area of the law. So I would just basically, the moral is use it responsibly. So, you know, if somebody has in their terms and conditions that they absolutely do not want you scraping, it's probably not a good idea to scrape from someone like that. So anyways, what is web scraping? Well, it's a technique basically in data extraction where you can systematically pull information from sites by specifying certain patterns. So mind you, that's the technique itself. So you could actually, if you want, you can have a pen and paper, be going through all of the sites and pulling the information out yourself if you want. So that's the general concept behind scraping, although typically it's done using software, which makes it much easier. So typically you've got a website, so we jump on a site, this is what we'll see, the actual HTML. I couldn't find a way to make that wider on short notice, so you guys are only getting a part of the page. And this is what the scraper likes to see. So the scraper goes in and sees the HTML itself, and based on what you give it, it kind of discovers those patterns from there. So what I set up for you guys today is a basic scraper for the IMDB site. So what it's going to do is we're going to use Google search, and we're going to put in a search term into there to retrieve a list of title links in pertaining to that term, and we're just going to scrape a little bit of information from each video. So right now I'm only pulling the title, the release year, and the rating, but we can play around with that once we get into the live code there, and I can show you guys how to get another piece of information if it's in there. So I'm also storing the data in a Postgres database, which I set up. The code base is available going to be available in my repo, and I'm also going to link to it in the UIT documentation. So that'll have the script to make the table for the database in there.
What do you need to scrape if we ask, if we got an API from them, right? Like if we could get access to their API, then it would be the same thing.
Yeah, in most cases, if someone's offering you an API, it's for those reasons, for access to their data, okay, in that type of environment. So yeah. Okay. So what I use to build this, so it's a Node project. So I used Express Server. I used the request function. So for those of you who don't know what the request function will do, it will allow you to actually request a page, and then you can pull back the raw HTML to do what you want with it from there. So it's pretty common amongst most languages. They have some sort of a basic request functionality. Cheerio is a package I found is what we'll actually use for extracting the data with the scraper. So I'll get into more detail with that as we go through. The Google APIs is what I use to invoke the custom search to get the information. Postgres obviously is a database I'm using to store the info, and body parsers I'm retrieving any form-based input. So the way the software workflow is going to look is we're going to launch the web server. It's very basic. I didn't delve into any kind of formatting at all, so you're getting very basic. Search box will enter the text we want to use to grab the movie info. The Google Custom Search will grab the titles, and then we'll use request to pull the information, traverse the DOM, and extract what we want, and then drop it into a Postgres table. So that's where the repo is located. Like I said, I'll link up to that in the UIT stuff. You guys can check it out from there and let me know if you have any questions from that point. So now the fun stuff. Okay, so I've got the project preloaded into here already. So it's very generic. We're using the same style of building the project that Jeff used originally, which I really like. So I found it kind of is a nice way to package up Postgres and everything. So I use something very similar. So you guys will be quite familiar with this here. These are just basic 2 templates I have to show each page. So the pages themselves in the project. So we've got all of our declarations up here. Crap, I shouldn't have shown that online. I'm gonna have to change my Google key now. So it's out there. It's done. So anyways, for these purposes, you guys will have to change this to your own key. This is a custom search, which I have already gone in and set up. So if you go to look up like Google custom search, you can create anything through here. Yeah, so as long as you have your Google account, it's quite simple to do. I know AJ's gone through it already, so I've just entered like the search engine name, which is UIT IMDB test. And in the setup here, so yeah, so I am searching for imdb.com/title/star, and I'm just excluding a couple of sites here which don't have the information we want on them. I think there's a bunch more, but I just found for our examples this is probably going to cover most of them, and it's not going to cause the software to break immediately.
And why do you use star, Rob?
Star is a wildcard. So what star is used for is could be anything in there. So in our case here, the star is the actual ID that pertains to the video itself. Thanks, AJ. Yeah, so that's basically how you set up your Google custom search engine. The only other piece of information you're going to need is your API key, which you can set up through your Google Developer Console credentials. So back to the code. So we'll go over this whole page with you guys before I actually run anything here. So we're setting our custom search and we're setting our API key. As we gathered them before, we're declaring all of our packages up here. So you have your Express, your body parser, your Google APIs. We set up the custom search API because that's the one we want to use. Your request package and your Cheerio package there. So we declare we're using our body parser. We've set up our Postgres database, and now we just have our first function, which is our get function that takes you to the index page, and all it does is display our template for us right now. So all the magic will actually happen in the form itself that's on that template page. So the form itself is going to submit via post to a page called scrape. So that'll be this page here. So what I'm doing here is I'm grabbing the search string from the page, and this is actually the CSE is for the custom search. So this is invoked using the Google APIs method. So we drop in our custom search there, we drop in our actual search from our form, and we drop in our API key. And we then check if there are errors. If there are no errors, we continue through. We're just console logging the result to show, I believe that shows the total number that it can retrieve. And then, so for right now, it's only grabbing 10 results, which is default. I'm going to look into how to actually up that a bit so you can grab like the top 100 results or something. And when I find out about that, I'll let you guys know. So,
is that limited by the API, or is that?
I'm not quite sure yet. So I gotta kind of dig into the Google Docs a little more and see how that kind of works out. Excuse me. I think it's requests, but that might be a parameter within the request, so we can see if you can kind of work around it there somewhat. So yeah, so what that'll give us back is it'll give us back a group of items, and within those items, it's got information like the page title, the link, and I guess a description. Anything else you would basically see in like a Google result. So what we're interested in here is the link. So we grab our link through this variable web link here. and then we use a request package. So request will actually reach out to that web link and pull back all of the HTML that's retrieved from there, which will be stored in HTML. So from there, we load the HTML into Cheerio, into the $ symbol, and then we declare our 3 variables we're looking to keep. And now this is where Cheerio is actually working here. So before we move on, I'm actually going to open up an IMDB page. And we don't want to see a trailer, but I would like to see a movie. So let's go with pixels. So we have this here. And now if we check out the source. So what you'll see if we look for, we have the title there, but that's actually not what we're looking for. We're looking for the header. Okay, so this is what we're looking for here, is this class here, header. So this is the H1 header, and it has a couple of the pieces of information that we're actually looking for. So when we find this by actually going through the HTML, which is something you're going to have to do for scraping anyways, you're almost always going to have to learn the nature of the HTML you're trying to scrape.
So you do have to learn the pattern and what the columns are?
Yes, exactly. So this is where this pattern will be on this page. So it's an H1 tag, and it has a class header. So if we go back into the code, we see that we are calling in a, has anybody here used a lot of jQuery? This is very jQuery-like, this code here. So yeah, so this is the header class, which we've seen in the H1 tag. It would be the same as if you did like h1.header, but there's only one, so we'll leave that there. So and then you invoke the filter function and give it an empty function here. So data is this, so it's pulling in the information from that header into Cheerio. And then if you look at the title, so it's data.children.first.text. So if we go back over, you have your H1 class here, so that's this. And then .children.first is the first child. So that is this here. .text is the text inside of it, and that's how we get the pixels from there. So likewise, when we were looking at the year, I believe it was .children.last. So data.children.last.children.text. So data.children.last, which is this here. So then you have children, so you have to go down another level into this A tag, anchor tag, and .text. So then it would grab the text from within there. So do you guys see how Cheerio's kind of working? You set your anchor on the page where you know that you're going to be getting some information from, and then you can just kind of traverse through those small parts to get to it. Whereas previously you would have to look at the page as a whole, determine this here particular pattern and how it was kind of standing out from everything else, and then try and pull the information out of it from there. So that's how Cheerio actually works. So if we look here at the second example, which is actually getting the rating, so it's the class called star-box-gigas-star. So
Rob, does that
oh, we actually can't see that because this movie's not out yet, so
that's
we
gonna
wouldn't
iterate
have.
10 times, and then it's going to be done that first function. It's going to go through loop 10 times and pull out the headers.
Yes. Yep. So exactly. So if we look at this, I'll show you how it works in approximately 2 seconds. One sec. So this is that star box giga star. So that's just its child, or sorry, it's text, right? So it's data.text.
Oh, so you really need to know what you're getting back. You're not going to be able to use this to do a general scrape across.
No, you need to learn the nature of the HTML you're looking at first, and that's going to come with the territory for any scrape.
And that'll be site
So,
specific. Right?
Yeah,
Jeez.
yeah. I don't think there's.
I wrote an XML parser in 2001. I thought we moved on. I thought it was all automatic.
Nope.
now.
So that's what we're looking at for Cheerio. So then all I do at the end of that, once I know I have those 3 functions, is I just add them into the Postgres database under the movies table.
Okay.
So let's hop over here into the command line.
Pretty cool, though.
That is pretty cool.
So if we check out movie info,
Hello, welcome to the movie.
select star from movies. So we got nothing in there right now. So what I'll do is I'll fire up the node project. I will hop into Firefox. Oh. We will jump into the project itself. So test the Google Custom Search Engine. We will click on Star Wars. So we've got nothing coming up right there. Let's give a little bit of white space. Click search. Scrape complete. Let's go look in the database. So, oh, we got an error.
It's not a lot going to without an error.
Of course it's not. So, anyways, as you can see, I believe there was a date that was a little too long there. I have the year, I believe, set to 25 characters only, so I don't know what's going on there, but mind you, not all scrapers are perfect on the first couple of runs. They usually take a little bit of refinement before you completely get the data you need clean. So anyways, but from running that, that's what just got dropped into the database, as you can see on the screen there. So it more or less, it pulled all of the Star Wars movies from IMDB. It gave us each year of release, which it looks like for the majority of them were its newest releases. So anyways, so want to go again, we can look again. Star Trek. So we go there. I'm channeling my inner nerd, exactly. So now if we look, we see we've got all of the Star Trek movies there. These here are TV shows, so they run a span, which means I think it's a slightly different HTML from an actual movie. So, you know, you can update the script to grab those things accordingly as well. So BEETLEJUICE. Search. Whoa, there's a bug. So you got Beetlejuice, which was actually released in 1988. So you know, you're getting some degree of accuracy anyway. So this is a very basic scraper. Obviously, I'm not really delving deep and grabbing any information, but really, if you can do it, there's no limit to what you can do, right? Like,
grab like an image link and do all that sort of stuff. There's lots of
yeah, exactly. Like, for example, like things I've done in the past is I was telling Carol about this yesterday. There used to be a site out there when GPSs were the big thing. It was called POI, POI, Point of Interest Friend. And what it would basically give you was you could search for something and give you a big listing of it. So like, say you searched like Tim Hortons, and it would give you like every Tim Hortons in Canada. So I may or may not have built a scraper at one point that would go in and like grab each of these individual items from this list, and they would just come up as a link, and if you clicked on them you could get the latitude and longitude. So you would get the list, and then each one you would systematically go through it and open up its corresponding link to get the information out of it that you would need at that point. So you know, depending on how in depth you want to make your crawler, there's a lot of information you could extract out there. So yeah, that's the basics of scraping. If you guys want to hear anything else, or you feel you want me to expand on this in a future session, just let me know. But other
So
than
you
that,
log that stuff to the console, and it also went into your Postgres too?
yeah, that's in my database right now.
Oh, okay.
So yeah, if you were say building a repository of movies or whatnot, you can go through and, you know, dump a bunch of things in there. If you had unlimited Google search, you could just create a big text file with all of the things you wanted to search in there, and you know, you could just run the program through there, and it would go through each one and do the search, grab all the info, drop it in there. So, any other questions, guys?
Looks like fun.
Yeah, it's not bad. You guys are free to download and play around with this code if you want. I'm hoping it's pretty easy for you guys to be able to manipulate it to do what you want. But if you are hung up with an aim point, just come get me. We'll sit down and play around with it.
Sites that don't give, like, I've always thought that, like, we could get access to most APIs if we, like, emailed them and asked nicely.
Yeah.
So, like, is that new? Is that, like, because people were scraping anyways, so, like, people started giving out APIs, or is there a reason why?
No, APIs are kind of the basis of the whole software as a service movement, right? So,
Okay,
you
so
know, if you're stingy with your data and you have it available out there, like maybe somebody does take the data, but for the most part, if someone has access to this and you need it for something,
Yeah.
an API is. So you're still using their data as opposed to pulling your own version,
But they
right?
also
And
control what they put out in the
They control what they put out as well, which is good and bad at the same time, because the other thing about if you're pulling in all of this information yourself, you also have to manage this information. So think of it in terms of like restaurants and things like that, where you can say a restaurant closes or something, right? Like, you would have to make sure that you're up to date on this information if you're storing it yourself. Whereas if you were using some kind of an API that just pulled this information in, at this point it's up to them to keep this data up to date, right?
Okay, awesome.
So, okay guys, so I'm gonna cut the session short, or I'm gonna cut the session off now, so if anybody has